This meeting is being recorded. So, hi everyone. It's me and Nelson again. This is today we are covering chapters 19 and 20. The book is still Eloquent Ruby by Russ Olson. So today we'll be finalizing with part 2, which is the second section of the book, and then we'll usher in part 3, which basically deals with metaprogramming, and that is the last part of the book. And for chapter 19, we'll look at the last section of code blocks. Because remember, we looked at code blocks for chapters 17 and 18. So this time around, we'll be looking at the last use case for code blocks. And then after, we'll look at hooks, which is a part of metaprogramming, and that is covered in chapter 20. So I'll be referencing the text from time to time. And currently I'm going to start at chapter page 234. Nelson, are you there?
I'm here. Can you maybe you can screen share the
Okay.
book?
How do you screen share again?
In the middle of the controls at the bottom of control panel, there's a green button with a up arrow.
Yeah. Yeah, so we have this block, this piece of code, and this is page 234. Is it okay, Nelson?
I don't know if it's going to work. You're very choppy now. I'm going to stop my video. Hopefully that'll help.
Okay. So I have this piece of code on page 234.
Why don't you
And you
stop
can
your
see
video
that.
as well? You're
Okay.
still sharing, but turn off the video for your face.
Okay.
Okay, let's see if that works.
Is it okay now?
Yeah, we're not hearing the static that we were hearing before.
Okay. So we have this piece of code. It's basically a method, and this method is it expects a block to be passed to it when it is called. So about this code, to explain it in detail, I have a few notes I took that I'm going to screen share momentarily. Yeah. So this is still the code we are looking at. This is a code on page 234, and it's basically a method. The name of the method is run that block, and the method expects a block to be passed to it when you're calling the method. So like we saw in chapters 17 and 18, you call the method and you pass in the block using this next piece of code below, whereby you type run that block, and then inside the curly brackets, you pass in the code block. So some of the behind the scenes stuff that happens when you do this, and this behind the scenes stuff is specific for explicit code blocks, which is the focus of this chapter. So what we are going for by using explicit code blocks instead of implicit code blocks is that we want the code block we've passed to this method to be available for us to use later on in our application. And when you think about some of the uses we could use the block for, we could assign it to a variable, and then we could use that variable for several other use cases. For example, we can pass that variable to a method for that other method to use the variable to do something else. So that is the thinking around using explicit code blocks. We want the code block to be available for us to be used later on in our program. So when you call this method, specifically the method named run that block, and you pass in the code block, given that this specific kind of method expects an explicit code block, which is specified by this ampersand. I don't know what to call it, Nelson. Is it okay if I call it a sign?
Ampersand is the a right term.
Ampersand, yeah, the ampersand. So Ruby is going to take this code block that you've passed to the method, and then it's going to turn that code block into a proc object by calling the new method on proc implicitly, and implicitly means that this is something that's going to the kind of syntax you'd have to write if you'd want to write, okay, to show how Ruby handles it behind the scenes. This is what you'd have to write, whereby you specify run that block, you open the brackets, and then you type proc.new, and then inside the curly brackets is where you attach your code block. But Ruby saves you from doing all that, so that you can just say run that block, and then you pass in the code block without specifying the call of the new method on proc. So Ruby takes the code block passed to the method, turns it into a proc object by calling the new method on proc, and then assigns that proc object to that block. In this case, that block is the parameter. And then we can call the call method, which is available for all proc objects on that block, because that block is a proc object. And what calling the call method does is that it's going to execute the code block. And therefore, if we were to check what we would see in our interpreter, you'd have the put, and you'd have about to run the block, and then you'd have this is a method that expects a block, because now here we are executing the block at this exact point, and then the final puts, which is done running the block. So those are the key takeaways. This is just some stuff that happens behind the scene, and the conversion of the code block into a proc object, which makes it okay for us to use the call method available for all proc objects to execute the code block.
Yeah, this
And yeah,
actually helps me make sense of something that I heard before about Ruby, and that's that everything in Ruby is an object, as we've seen throughout this book, except
yeah,
for blocks. And I read that somewhere, and it really didn't make sense to me because you can you know when you call the block, you do block dot call, right? So you're obviously calling some method on an object, and I really didn't
yeah, yeah,
understand what was going on. But so this chapter made it a little bit more explicit in what was going on, in that the block itself isn't the object. So everything else in Ruby is an object except for blocks. Blocks get turned into objects uh, with proc.new, and that's why we can say blocks are the only thing that are not objects in Ruby.
yeah. So then another thing I would like to point out is the ampersand, which is basically a way of telling Ruby, or specifying to Ruby, that when code block is passed to this method, it should be treated as an explicit code block that is supposed to be turned into a proc object. And therefore, if we were to omit this and then you try to run the code again, I think you'd run into an error. Because first and foremost, you won't be able to use the call method on that block simply because it's not a proc object. And also, this kind of method, in addition to the code block you've passed to it, it won't be treated as an explicit code block. So that is something to note about the ampersand method. So I'm going to go back to the book. That was just So still page 234, I think that example is, I've tried to explain it, and then to highlight on the importance of explicit code blocks as per the text. When you use explicit block parameters, you can hold onto the block and store a reference to it like any other object. And that means you can execute the block later, perhaps much later, possibly long after the method that called the block has returned. Oh yeah, and this is also something to note, that when you look at an implicit code block, you can't execute the code block outside the method that is associated with it. And by an implicit code block, I mean that kind of code block whereby I would execute it with the yield keyword. In that case, you can't execute that code block outside that individual method. And this is different from when you look at, for the case of explicit code blocks, whereby you can execute the code block inside the method that is associated with it, and then outside the method itself. So yeah, now we look at an example that tries to make it more easier to understand the concept of explicit code blocks. And here we are trying to, I'm going to reference the book. To see the utility of being able to hold on to code blocks, let's imagine that some of your colleagues are writing copy edit, a word processing program built around your document object. The copy edit folks are thrilled with the Zen-like simplicity of your document class, but they have requested an enhancement. They need a callback to go off when the document is read from a file, and another that will fire when the document is saved. So the author gives you a traditional way of solving the problem, and that is by using listener objects, whereby you have an onSave listener object and an onload listener object, and of which each of these listener objects is inside its own class. So you have a document save listener and a document load listener to make two classes. And then inside the document class, because now you're going to reference the document listeners, you create a load method and then a save method, and these are instance methods. And you'll have inside the load method, you have load listener, and then you call the onload method onload listener. You pass in the self, which is related to the current file that you're dealing with, if the load listener. Same goes for the save method. And then he shows you how this exact thing you can run this code inside the interpreter. So you create a new document instance object, and then you call load listener on it, of which you assign load listener, you assign doc.load listener by creating a new instance of the document load listener class, and then you do the same for the document save listener class. And then after getting these last two instance objects, that is when you're going to finally be able to call the load method on the document instance object, and then the save method on the document instance object. And of course, you'll get the output like he specified it here. You'll have, hey, I've been loaded, and hey, I've been saved. And then now he ushers in the approach which uses code blocks to solve this same exact problem. And this is page 237. You have a document class, and inside the document class, you create the onSave listener as an instance method. You also create the onload listener as an instance method. Same goes for the load and the save method. And then what you are going for here is that this code block is only going to be called if you specify that it should be called. And I think here you can see that he uses the call method, because remember we've seen that the call method is available for proc objects. He uses the call method, and then he passes in the current object or the current file he's dealing with along with the path. But then he specifies that this call should only be made if the load listener is available, or if the method has been called and at the same time a block has been passed to that method, that is the only time the call method should be called on load listener. So he does the same for the save listener as well, still using the call method which is available for proc objects. And how is this a better approach to what we saw before, whereby we create two new classes, and then inside those classes we specify the listeners. So what we see here, this is page 237. We create a new instance of the document class, and then we pass in the arguments as usual. So we can call the onload method on that new instance we've created and pass in the block that whose output we want to have in the interpreter. And instead of us having to create two new instances of the other two classes we created, in to be specific, these are the document load listener class and the document serve listener class, we do away with this entire step so that we only create the new object and then we call the listeners on that exact object without having to instantiate two other objects. And that is why this approach is better and more concise according to the author. I don't know, Nelson, if you have something to add upon that.
So you see this pattern a lot in libraries where so like Ruby on Rails uses Active Record to be able to save information to the database. Obviously, like uh, Ruby on Rails, the developers of Ruby on Rails cannot know everything that you want to do um, when you're putting information into the database or getting information out of the database. So they provide active record callbacks that where you can inject, arbitrary code into the life cycle of a of saving and loading information. These are things like before save. Okay, so they provide a before save on the active record object, which means like here, before we save this, I need to be able to do some arbitrary set of instructions, and it's really handy. Um, but at the same time, you know, it's when you're uh, it does make it sometimes a little bit harder to trace everything that's going on in your program. Um, and if you do too many of these, you end up in situations where you start introducing bugs that are much harder to find. But it is like it is one of it is a very clever way, and it's a very succinct way to allow users users that you have no contact with to be able to do any like to have a whole lot of power. But like when you give users a whole lot of power, obviously they can do some things that are not great with that power.
Okay. So I think we'll be moving on to the next part, which is page 238. We'll look at another example. And what we are going for is that the author introduces this hypothetical situation whereby usually you want to display for archival documents, you want to all the time you should display the title as well as the author of the document. But also at the same time, in cases whereby now let's say the reader wants to see the content of that specific document as well, you can use a code block to only display the content when the user wants to actually view the content, instead of displaying the content all the time, even when the user doesn't care about it or the reader of the document doesn't care about it. And that is what this example is about. So you create a class, and this class is called archival document, the attribute reader is the title and the author. And the point of interest is the path that we pass in when the path that we pass in when we are creating an archival document. And quoting from the text, at first glance, the solution shown here seems fine, but it does have one real drawback. The problem is that the archival document class knows all about where the document content comes from, specifically a file. Contrast this with the original document class, which neither knew nor cared where its contents originated. With archival document, if you suddenly decide you want to get your document text via HTTP or FTP, well, you're kind of stuck. Fortunately, we can fix this problem with a simple wave of our saved code block 1. Instead of passing in a path when we make a new archival document instance, we pass in a block, one that returns the document contents when it's called. And that is the code on page 238 towards the end, as well as page 239. And here you can see that inside the content method, we ask ourselves did this method, was this method called along with a code block? And if yes, we execute the code block and then we assign what it returns to the content variable. And that is the line that is bold, within the content method. So here you just check when this method was called, was a block passed to it? If yes, get what the block returns and assign it to the content variable. And then after that, you see that the final output, or what this content method is going to return, is the actual content, of which the content is what was returned by the execution of the code block. And how is this better than the previous solution of accessing the file path? So in my opinion, this exact approach is more dynamic compared to the one before, in that we can we no longer have to rely on the path of the file, in which case the path has to exist on your machine for you to be able to create a new archival document instance. But instead, we can have cases whereby
Hmm. Gonna wait for him to. We're gonna wait for his internet connection to reconnect. Hopefully, it'll come back soon. Well, screen share being gone is not good. Hello?
Hello, Nelson, can you hear me?
Okay, now I can hear you.
Oh, sorry about that.
Yeah,
So
no
where
problem.
had I stopped? I don't
Yeah,
know
you're
where
gonna have to reshare your screen.
okay. I don't know where I had left off from, but I'm currently sharing.
I don't see anything.
You don't see anything.
Hold
How
on one
about
second.
now?
It's loading. Okay, great.
Okay.
Okay, so you were explaining the benefits of using this style, and the last thing you said was basically like that the you know you no longer have to this uh, this class no longer has to concern itself with the with knowing the path
Yeah.
that the path can be known by the user, and yeah, that's where you cut off.
Yeah. So what I was saying basically is that this approach is more dynamic and better than our initial approach, simply because it is not limited to the file that is being read or the file whose content is being read, specifically the document, to be
Hmm. Sounds like his internet cut off again. Hello?
yeah, hello.
Okay. You're gonna have to screen share again.
Yeah. So like I was saying, sorry about the interruption, but hypothetically, if we have a document and that document is not available on the local machine, but rather is available on the internet, we can get it via HTTP, given our now dynamic approach to the problem, instead of us having to rely on the file path. So that is why this specific approach is better than the one that relies on knowing the file path. And then this is another section, instant block objects. Sometimes it's handy to produce a code block object right here, right now. So what we are seeing here, this is code on page 240, is that we get a code block and we assign, I think this is a constant. Is it Nelson?
The default load listener is a constant, yeah.
Yeah. Yeah, so we get a code block and we assign what it returns to a constant. And here we create two constants. One is the default load listener and default save listener. And then we assign those two constants to two instance variables. So we assign the default save listener to the save listener instance method. And then we assign the default load listener to the load listener instance method. And remember previously we were turning the code block into a proc object and then calling that using the call method, which is available for all proc objects. We call it we call that call method on that given object. And in this case, we'll just need to say save listener dot call. We specify what to pass in if save listener. And that is kind of what we were trying to do before. Only this time around, we specify that save listener is an instance variable, but it equates to the default save listener, which is a constant that we defined before the initialize method in this class. So finally, staying out of trouble.
Yeah, well, hold on one second. So when we were
Okay.
using the blocks previously, the user of the or class uh, would basically define a code block, you know, with begin and end or do and end. And and like you said, that block would get turned into a proc and then called. Um, Doing it that way,
Yeah.
the it's basically you don't have a handle to it, right? Like you, it's basically an anonymous code block. It doesn't have a name. You can't really pass it around. Uh, and here we're saying that because you can't just name anonymous code blocks, or in the previous syntax that we've seen, you can't do that. Here they've given us a new thing called a lambda that allows us to then assign um, this set of instructions to some variable. And that variable we can hand off to this class, we can hand it off to other classes, we can move it around. And so it gives us the power of being able to say, okay, I'm going to set up some default lambdas here and then use them where I want to. Um, so I think it's a subtle distinction, but I think it's an important one to make. Okay, that's it.
Yeah. So we have a few minutes left. I don't know if I should try to breeze through the next chapter, or
Let's
we
just finish this
create
chapter.
another
Okay, let's finish the
meeting.
staying out of trouble. Are you still there? Oh, you're not there anymore.
Okay.
Let's just finish this staying out of trouble, and then we can move on to the other Zoom room, to the other chapter.
Oh,
Hello?
okay.
Um, so, um, yeah, staying out of trouble.
Okay. Okay. Hello.
The
Nelson.
yeah. Okay, so I was really looking forward to this section because I didn't really understand the differences between procs and lambdas before, and it made it this section made it a lot more clear as to lambdas being a lot more like uh, the eh, like if you want something to behave more like a regular single method with with expected parameters, you're going to use a lambda. And for procs, they're a little bit less strict in what they take. So if you give it more parameters than it requires, it just ignores those parameters. If you give it less parameters than it needs, then it just sets the other parameters to nil. And it's a very, very important thing where that could cause a lot of bugs. And for me, I would prefer using lambdas where possible. Otherwise, uh, you have a lot more room to make mistakes in procs, where it
Yeah.
doesn't, it'll just like gracefully try to run instead of stopping and giving you an error when unexpected parameters are there. I don't think um, I'm not sure where it talks about this, but the other important thing in this chapter was, um, and they don't use this terminology, um, but the terminology is closures. And I'm not sure why they don't use the closure terminology, but basically the idea is that you have when you define a code block, it remembers all the variables that are in scope. And because it remembers all the variables that are in scope, it's very convenient.
Yeah.
You can call you can use everything that you expect to have been there when you wrote the code block. The problem is that sometimes those variables hold a lot of things in memory. And if they take up a lot of space, then what happens is that the garbage collector is not going to be able to reclaim that memory. So uh, you have all of this memory that you may or may not be using, and so um, it could lead to using up more memory than you expected. And the fix to that he described was just to set huge variables to nil after
Yeah.
you do something with them.
Yeah, I think that is the last part of the staying out of trouble. The next part is in the wild. And I think you mentioned the examples below because he references examples from Ruby on Rails. Now,
Mhm.
like this before filter and the active record lifecycle hooks after destroy, after create, after update. Yeah,
Yeah, those are very, very handy.
yeah.
Yeah, I think that's the
So
end of the chapter.
yeah, I think we can move on to the next. And yeah, that's it.